uniform circular motion. And before we even start doing any problems, I want to give you just one heads up. And that is this. Remember in chapter 4, every single problem we had to do a free body diagram, you know? And then once we did a free body diagram, you do some of the forces in the x direction equals max, and some of the forces in the y direction equals may. Well, here in chapter 5, this is all about circular motion. So with circular motion, on every problem you're going to do this. First, you'll do a free body diagram, and then on every problem, you'll do some of the forces in the x direction equals may. You guys okay? So it's nothing different except for the end. You're not even learning any new forces. We got tension, gravity, normal force, friction force. That's good enough. You're not learning any new forces this chapter either. The only thing that's going to be different is one of these two accelerations on the right side of these equal signs. Nothing on the left side is going to be different, but on the right side of the equal sign, one of these two accelerations gets to be v squared over r because you're running around in a circle. Other than that, everything you do in this chapter is just like what you did in chapter 4. You guys okay with that? Just one of the accelerations will be centripetal acceleration, and you get to put v squared over r in for that acceleration. That's the only difference. Well, let's get started. Please look at example number 1. Excuse me. And I apologize for my horrible coughing. I was sick all last week, or most of last week. But I'm not sick anymore, but I have a cough. Example number 1, I want the average speed. Average speed. Well, average speed is distance over time, right? Tell me, what's the distance that this car travels? What? 50 meters? I'm so sorry, that's totally wrong. What does it say, Chris? What? Yeah, the circumference of the circle, right? This car is moving in a circle. The radius is 50. Gosh, is there some formula for circumference?
2 pi r.
Think you guys thinking 2 pi r? Hope so. Yeah, so 2 pi r. And that's what's going to be true for all these problems. They're going to give you radius. They're going to expect you to find the circumference. So yeah, you're going to have to do 2 pi r. So in this case, it's 2 times pi times 50 meters over, what, 35 seconds? And so when we do our division, I don't even remember what it ends up being. What is it? 10 pi, clear, 100 pi divided by 35. So it's like 8.9, about 9.0. Okay, so you guys okay with that? So that's the first type. Sometimes you'll be given a situation where you're going to have to find velocity. Other times you're going to have to switch back and forth between velocity and RPM, or RPM and velocity. Look at example number 2. A gear of radius 8 centimeters rotates at 4,000 RPM. Find the speed at the edge of the gear. Well, you're going to convert RPM to meters per second, and so you're going to treat it like a conversion problem. Who can tell me, what does RPM actually stand for?
Revolution per minute.
Good. And so you're going to use those units, revolutions per minute. And now I need to convert to meters. So I'm going to have a conversion factor that gets rid of revolutions. So tell me, where should my revolutions go, top or bottom? Good for you guys. So you guys are on this. Yeah, bottom. I got 1 revolution, meters. What is 1 revolution again? It's a, what? Yeah, it's the circumference, 2 pi r. That's 1 revolution. So yeah, I'm going to do 2 pi. But you'll notice I want to get it in meters per second, and they gave me their radius in centimeters. So what am I going to have to do? Hopefully they can convert to meters. So 8 centimeters is 0.08 meters. Oops. So now I've got meters instead of revolutions, but I still got to get rid of the minutes. So I've got 1 minute is equal to 60 seconds. And now I can multiply and divide. 4,000, oops, clear. 4,000 times 2 times pi times So 8 divided by 60. So I get 33.5 meters per second. You guys okay with that? Now, one thing I want you to be aware of is I do need you to do the punchy and get right answers. On that last quiz, I had a whole bunch of people who would correctly do this. Like they knew it was this times, and I'm just making this up, I don't remember exactly what it was, over this and then 7.2 times 10 to the 8th power squared. You know, they correctly wrote this down, and then they would get an answer that was totally wrong. I didn't take points off. If you wrote this down correctly, then I gave you credit for the most part. But on our next test, I am going to expect you to be able to get right answers. You can't not be able to punch that into your graphing calculator or your Dollar Tree calculator, whatever it is you're using. And so if you can't consistently get right answers with this, then you need to see me, and we need to have you do a way that will be more certain for you, a way where you know you'll get a right answer every time. So make sure you can do the punchy and get right answers. That's really important. Okay, here comes another example, an example you guys are going to do. I'll call it example 2A. Okay, but what if I had this? A wheel of radius 0.5 meters. Its edge has a speed of 25 meters per second. So I've got a wheel that's spinning, and its edge has a speed of 25 meters per second. Find the RPM. Please do this now. How many revolutions per minute is this wheel doing if its edge has a speed of 25 meters and it's a wheel of radius 0.5 meters? If you don't know how to start, I will tell you, please write down 25 meters per second and then go ahead and start the conversion process. You need to get rid of meters and get revolutions instead. You need to get rid of seconds and get minutes instead. Done, Nicole? Then I'm going to take you as the bellwether. I need to get rid of meters, so I need meters down here, which means I'm going to have revs up here. I got 1 rev in 2 times pi times 0.5 meters. And then I got to get rid of those seconds, so I'm going to have seconds up here and minutes here. I got 60 seconds in 1 minute. Okay. I had a student who was not able to do this correctly, could not get a right answer, so I had to show him how to do it. So make sure you guys know how to do this. So I got 25 times 60 divided by 2 divided by pi divided by 0.5, and I got about 477. Anyone here get 477 RPM? Yay. Okay, so that's all the math you need to know to be able to get speeds and relate speeds to RPM and RPM to speeds. Now it's time for us to learn the physics. It's time for us to learn about centripetal acceleration, centripetal force, and uniform circular motion. Please do me a favor and read where it says centripetal acceleration of force, read that until you get to example 3. So please read that now. Are you done reading? All righty, then you will be my bellwether. Okay, I'm going to assume everyone's done. So let me ask you this question. This yo-yo is going round and around in a circle, okay? Tell me, what is making it go round and around in a circle? Yeah, centripetal force. What's providing that centripetal force? Yeah, the string, not my hand. My hand's not touching the yo-yo. The string is, okay? So let me ask this question. As this yo-yo goes round and around, let's say when the yo-yo's right here, I cut the string, so now the string's no longer providing any force. So my yo-yo's going round and around, and then cut, or cut. I cut the string right when the yo-yo is horizontal, you know, right when the yo-yo is here. Tell me, is that yo-yo now going to fly off in that direction? Or is the yo-yo going to fly off in that direction? How many people say it's going to fly off in that direction? Okay. How many people say it's going to fly off in that direction? Alrighty. Hey, well, there's one way to find out. I'll do it. Here we go, only I'll just let go. I won't cut the string. I'm going to let go right when it's there. Ready? Which way did it end up going? Straight up, right? Because according to what you read, according to the section you read, what direction is the instantaneous velocity of an object going in circular motion?
Tangent.
Yeah, tangent to the circle. And so if my circle is like this, what direction is this tangent line going to be? Vertical, correct? You see that? Vertical. Alrighty? If I wanted my yo-yo to go in that direction, where am I going to have to let go of it? Yeah, at the bottom here. I'll let go of it at the bottom. And now it goes in that direction. You guys see? Thank you for getting my yo-yo for me. Okay, next thing. The force that's making the yo-yo go around in a circle is tension. You know that's true because if I cut the string, it's no longer going in a circle. It goes in a straight line. What is the direction of the tension force always directed towards? Say again, Logan?
Center.
Yeah, whether my yo-yo is here, right? Tension directs it to the center. Is tension making it go that way? No, tension doesn't work. Remember, tension doesn't work that way. Tension only works this way. You know, what's the direction of the force on the yo-yo here? Towards the center. Direction of force there? Towards the center, right? And so this force, which we call a centripetal force, we call it centripetal because it is a center, centri, and then petal means a seeking, and I'm just taking someone's word for that. I didn't know that. But a center-seeking force is a centripetal force. It is a centripetal force that's making this guy go around in circle. But the thing is, I'm not teaching you a new force. There's no new force called centripetal force. All this means is that the forces we already know can, on occasion, provide a centripetal force to make something move in a circle. So for example, to make this yo-yo move in a circle, the centripetal force is tension. But what about the moon orbiting the Earth? What's providing the centripetal force for the moon to continue going round and around in a circle and not just fly off on a tangent? Yeah, gravity. So there's no new force, it's just gravity. If you did sum of the forces equals ma, on the left side of the equation is gravity, not centripetal force. It's just gravity is providing the centripetal force. Tell me, what if I have clothes in a dryer? Here, let me even make a picture of that. Here's my dryer, and here's some garments in the dryer, clothes in a dryer, okay? And those garments are going round and round. Tell me, what's providing the centripetal force for those garments to go round and round in a circle? What force is providing the centripetal force? What's that in mind?
Normal force.
Yeah. How many people were thinking a normal force? Sure, because it's got to be a force directed towards the center of the circle. And the only force that could provide that is the normal force. That is, I have the surface of the clothes pressed against the surface of the wall of the dryer. And so that force that the wall of the dryer exerts on the clothes is normal force. If I had a trap door in the dryer, okay, if I had a trap door right there, the clothes would leave the dryer. Would this garment shoot out in that direction? If I open the trap door of my dryer? No way. What direction would this garment go? Yeah, go ahead, Nicole, say that again.
It's just going to be the tangent line. So.
Yeah, it's going to go off like that. Essentially, the dryer would sling that piece of clothing in that direction. You see? It wouldn't just go out that way, it would get slung that way. Okay? And then finally, what if I had a car on a road? Here's my road, here's my car, okay? And my car is going around in a circle. So if you look down on it, and your car would look like this, okay? And it's going around in a circle. Tell me, what's providing the centripetal force for this car to go around in a circle? How many people are thinking friction? Yeah, good for you, friction. And you know that to be true, because what if this car hit an oil slick or wet ice? Instead of the car making this turn, what would the car do?
Skid out.
It'd skid out, and which direction would it go?
Tangent.
Yeah, straight tangent to the circle. It would just continue that way. Yeah. Okay, well, hey, let's do a bunch of examples. First, example number 3. Here's example number 3. They say a 0.25 kilogram mass attached to a 1.0 meter string completes a horizontal circle in 0.42 seconds. Find the speed of the mass. I hope you guys get that this is just another of those 2 pi r over time problems. Distance is 2 pi r, time is whatever the time is. So about 2 times pi times, what is that, 1 meter? 1 meter over my time, which is 0.42 seconds. So that's going to get me, just believe me, 15 meters per second. Part B, they want to know the centripetal acceleration for the mass. Well, in previous years, I would derive for my students what the formula for centripetal acceleration is, but I don't do it anymore because, I don't know, it had a bunch of vectors in it. It was really interesting, but it didn't really help my students, and it just was a big waste of their time, I guess, even though I enjoyed it. So you're just going to have to believe me. Centripetal acceleration is v squared over r. Just, learn it. What is that? Learn it, live it, love it, just there it is. So please plug in. What is the centripetal acceleration of this ball? It's moving at 15 meters per second on a radius of 1 meter. Mm-hmm. hopefully you see that the units work out. Meters squared over meters means just 1 meter. Second squared, the second squared would stay there. So I got 225 meters per second squared. Tell me, is that a large acceleration? Would you want to be undergoing that sort of acceleration?
No.
How many G's, if anyone knows what G's of acceleration are, how many G's would that be?
2.
Not 2. What's that?
You just divide it by magnitude.
Or how about divide by about 10? So how many G's is that approximately?
About 21.
Yeah, 22.5 G's, right? That's a huge acceleration. I mean, if you go to Magic Mountain, the most G's you'll be exposed to is maybe 2 or 3. That means if you were on a roller coaster that exposed you to 22.5 G's, you would weigh 22.5 times more than what you presently weigh. That's how you would feel. I mean, that's almost like a centrifuge. Essentially, all your blood would go to your feet, and I don't know, you'd just become your constituent parts or something. I mean, yeah, no human could survive that sort of G force, you know? Okay, and then finally part C, find the tension in the string. That tension is what's providing the centripetal force, so it'd be mv squared over r, which is ma. So you just got to 0.25 kilograms times 225 meters per second squared, and that gets you're about 56 newtons. Okay. So that's how much tension force the string is providing, 56 newtons. We now have to hit some more difficult problems. Please look at example number 4. Go ahead and read it, and then I'm going to go through it with you guys. Okay, so I've got a car on an unbanked turn of radius 50 meters. And what you're going to have to do from now on these more complicated problems is you're going to have to do free body diagram, sum of the forces equals ma. Let me show you. This car, you got the weight of the car, you got the normal force on the car, and then what force is providing the centripetal force for it to move in a circle?
Friction.
Good, friction. In this case, static friction. All right. I'm going to define up as positive and to the left as positive. And now I got to tell you, you don't do anything different. You just do sum of the forces equals ma. We know we tend to want to find normal force first because we need to plug that into friction. So we do sum of the forces in the y direction equals may, and sum of the forces in the x direction equals max. Except for one thing. Remember what I said at the outset? One of those two accelerations gets to be v squared over r. You tell me, which one is going to end up being? Is it going to be the acceleration in the y direction or the acceleration in the x direction that's going to end up being my v squared over r? How do you know the x direction?
Because the car's not floating.
What's it, Amani?
The car's not floating.
Good. She's going, well, the car's not accelerating in the y direction at all in the least, so it must be the x. Is there something else that tells you that the centripetal acceleration must be in the x direction? Thank you, because the centripetal acceleration has to act towards the center, and the only vector going from car to center of circle is a vector in the x direction. You know, or another way to look at it is, hey, what's the direction of the centripetal force? Whatever the direction of the centripetal force is, that's going to be the direction of your centripetal acceleration. So you know it's going to be in the x direction, not the y. So let me zip through this one. I got normal force minus mg equals 0, or normal force equals mg. And now I turn to the x direction. All I got is static friction force equals m times, here I get to put v squared over r, correct? And then my static friction force is mu sub s f sub m. And my f sub n is mg. Let me ask you one question. Why is it when you're driving on the road and you see one of those big yellow signs that says 45 miles an hour max, why doesn't it have a big yellow sign that says small cars, maximum speed 55, medium cars, maximum speed 45, big trucks, maximum speed 35? Why don't they do that? Why are they able to just put 1 mile per hour speed on a curve? Yes, Logan? Yeah, because the masses cancel out. As long as they have all the same types of tires, which we all do, you know, the masses cancel. Doesn't matter how big your car is. So I've got my radius, which is 50 meters, times my mu sub s, which is 0.900, which is given in the problem, times 9.8 equals v squared. So I take the square root of both sides of this equation. And just believe me when I say v ends up being 21 meters per second. What if instead of riding on the asphalt, on dry asphalt, I was riding on wet ice so that the coefficient of friction is 0.1 instead of 0.9, okay? Is my maximum speed going to be bigger or smaller?
Smaller.
Smaller, right? Because that guy got smaller. In fact, someone who's good at math, tell me, example number 5, because my coefficient of friction is now 1/9 what it was on example number 4, and I'm taking the square root of mu sub s times g times r, and this is 21 meters per second, what is this speed going to end up being? How many people say 7? You guys are good at math. Good for you guys, good at math. Yeah, ends up being 7 meters per second now only. You go faster than 7, you skid out. Now, we're down to our last minute, and I want to do a free body diagram of example number 6, and I'm so sorry, I'm going to keep you an extra like 30 seconds. Example number 6 is that ride at Magic Mountain where they put you in a circular room. Here's example number 6. They put you in a circular room, you stand up against the wall, okay, and then they spin that circular room really, really fast, and then they drop the floor out from under you. Okay, but you stay stuck to the wall. How many people have been on that ride? Okay, very fun ride. Let's do a free body diagram and then some of the forces. One force acting on you is gravity. What's another force acting on you?
Friction.
Good, friction. Which is the direction of friction force? Remember, friction force is always parallel to the surfaces in contact. What's the direction of friction force?
Upward.
Is everybody seeing that friction force is upward? The same reason why this piece of paper doesn't fall down, because of friction, is the reason this guy doesn't fall down. And let me ask, what's another force acting on this guy? Yeah, normal force. What's the direction of normal force?
Towards the center.
Towards the center, because his body is pressed against the side, so it's toward the center, right? Towards the center, and that's the normal force. So let's go ahead and do some of the forces in the y direction equals MAY, some of the forces in the x direction equals MAX. Who's going to get the v squared over r, AY or AX? Hopefully you're seeing it's going to be towards the center of the circle, a sub x. So in the y direction, I got static friction minus mg equals 0. And the x, just a second, normal force equals mv squared over r. And now you can answer any question they ask. They'll give you all of the values but one, and you'll have to find what that one value is. But as long as you're aware that this is the free body diagram, you'll be fine on this type of problem. Alrighty, hey, good luck, you guys.